Okay, Year 10. Question 13, the first part, has a real conceptual twist. First of all, I want you to think about 1 centimetre, what that is, and then 1 centimetre squared and what that is as well. And finally, 1 cubic centimetre, 1 centimetre cubed. If we think about these in terms of millimetres, the first one's pretty straightforward. 1 centimetre is 10 millimetres. However, 1 centimetre squared is a bit different. If we convert our lengths into 10 millimetres and figure out the area that is 1 centimetre squared, using millimetres instead, we get 100 millimetres squared. You can think of that as like a big grid, an extra large chessboard of millimetre squareds, and there's 100 of them, 10 by 10. It's the same concept when we look at a cubic centimetre. We don't change centimetres to millimetres once, we change them 3 times and then recalculate volume. And that gives you 1,000 millimetres cubed. So that's the key. 12 lots of those would be 12,000 cubic millimetres. Now, finding the upper and lower bounds of the mass of the cube. Starting from 87 grams, we think, how is this rounded? It's rounded to the nearest gram. So we think about what that means. Well, these are other numbers either side of 87 that are also rounded to the nearest gram, and we're looking for the boundaries between them. In particular, the lower bound of 87 and the upper bound of 87. Those are going to happen at 86.5 and 87.5. Those are our 2 values. Technically, you can state the upper bound as 87.49999 recurring. However, you do have to get that perfect. You have to have the recurring sign and everything. And why not just write it 0.5? It makes much more sense. To start this part of the question, you needed to recall the density formula. Density equals mass over volume. If you got it as mass times volume, you were wrong from the start and you would lose pretty much all the marks. You then need to recognise you're looking for the upper bound of density as it states in the question. So you need to recognise you're finding the upper bound of the mass over the lower bound of the cube. That's 87.5 over 11.5. And here is the answer of the cube, the density. I don't really mind if you've rounded it, but that's the exact value at the top, and this is in grams per centimetre cubed as asked in the question.